Hello students, we are back with recorded lessons version 2.0. We are on page 10 of our student booklet and we are in day 2 as well. And in this video, we'll have two videos again, but in this video I'm going to do examples number 1 and number 2, and then there'll be some time for you to do a little bit of practice. You'll get through this video pretty quick, I'm going to imagine. So we'll just go ahead and get started. In this video, we're going to start to talk about using the distributive property to simplify an expression. So the standard distributive property is written as I can take any three numbers, a, b, and c being any number, and a times the quantity b plus c is equal to a times b plus a times c. So in effect, what's happening is you're getting distributed. Now, as far as numbers are concerned, let's pick any three numbers here. Let's take 3, 2, and 5. So if I found my normal order of operations, it would say that I could take 2 plus 5 and get 7, and 3 times 7 is 21. But what the distributive property is saying that I could look at this as a product, 3 times 2, which is 6, and 3 times 5, which is 21, and then add them together afterwards, and I get the same answer. So if I mix multiplication with addition, I could actually, the distributive property says that the order in which I do this, and I could distribute first and then add secondly. So, all right, our first example is just to show you a connection between the way that you did math in middle school or elementary school versus the way that we do this when algebra is applied. So we're going to consider the product 4 times 15. Well, our standard algorithm tells us that I'm going to take 15 times 4. I'm going to go, okay, 4 times 5, which is 20. I'm going to carry a 2. Hopefully this is not news. This is not brand new. 4 times 1, which is 4, plus 2, which is 6. So I would get 60. Right? But noticing that the process that you're following here with the standard algorithm is distributing, because you're multiplying the 4 by both the 5 and by the 10, or by the 1, which in reality is the 10. So now we're going to look at this as a more horizontal type problem. If I were to take 4 times 15, but decide I want to break up the 10 and the 5 and make up the 15, I'm having a tough time speaking right now. Take 15 and separate it into 10 plus 5, which is actually the way that elementary students are being shown right now. Maybe you remember this. And if I, in a sense, distribute this, okay, then actually, no, let me read the problem. Represent the equivalent product as repeated addition of 10 and 5. Well, that means I get 10 and 5 4 times. Okay, and I can add all the 10s together and get 40, and I can add all the 5s together and get 20, and I can add the 40 and the 20 together and get 60. Or if I look at it from the standpoint of the distributive property, which states that I can take the 4 times the 10, 40, and I can take the 4 times the 5 and get 20, and then add them together, and you see that you get the same thing. So the standard algorithm, or an algorithm is basically just a arithmetic rule. Just says that, I'm going to multiply 4 here and 4 there. Okay? But realizing this is really 4 plus 5. Right? So enough about problems that you've been doing since elementary school. Now let's talk about algebra. And in Fast and Furious the other day, we actually did these problems, and most of you were actually very good at this. But I do want to show you this area model, about how we can model with area. Because the standard formula for area is equal to the length times the width, or the base times the height. So here, if we apply the distributive property, we could take 5 times 8x and get 40x, and we take 5 times 3 and get 15. But here's how the area model works. You can make a rectangle, okay? And I'm going to take the 5 and I'm going to put it here. And then I'm going to take the 8x plus 3, I'm going to put it here. And what I'm going to do is I'm going to make 2 different boxes. Now to find the area of something, like if I had a 5 by 8 rectangle, okay, this is not drawn to scale, the area of this would be 40. Well, here I'm going to take 5 times 8x, and I'm going to have 40x. And then I'm going to take 5 times 3, which is 15. And when I combine these, when I add these two areas together, I get 40x plus 15. All right, so it's just another way to look at this for those of you that need a more visual representation. All right, so then moving on to this one, here's a distributive. If I distribute a 4 to each one, well, this is an easy one. 4x plus 4y plus 4z. Okay, that's the distributive property. And here's the area model. 4. I'm going to make this rectangle a little bit longer because I have this broken into 3 terms. Okay. Okay, so I have x plus y plus z, and I just use the pluses here as a break point. So here I'm going to have 4 times x, 4x, 4 times y, 4y, 4 times z, 4z. Okay, so you get the same thing. So obviously it's going to be up to you whether you decide you want to use the area model or if you rather just use a straight distributive. I'm going to go on my gut and say that most of you are going to stick to distributive though. All right, C. This one, don't let this one fool you. This does look a little bit backwards, but if you think about it, we could actually distribute in the other direction. So I can distribute to 3 here, so this becomes 3a. 3 times 2b would be 6b, and I do have to put the plus sign. Now careful on this one. It's 3 times negative 5. 3 times negative 5 will be negative 15c. And that's one thing you'll have to be careful of is the signs, and that seems to be where most mistakes are made. Okay, here's what the area model looks like. Okay, here's 3. I'm going to put the 3 on the right side, and now I have a 2b minus 5c. Okay, so I have 3 times a, which would be a positive 3a. 3 times 2b, which would be a positive 6b. So I can put a plus sign, and then a 3 times negative 5c would be a negative 15c. All right, very good. All right, so that would conclude this video, and what you're going to do is you're going to hit pause, actually. And once you hit pause, you're going to do exercise 1 on page 11. So we will hit pause now. All right, and we are back. And you can see that I actually just stuck to the distributive property for each one. One of the hardest connections between algebra and arithmetic is understanding that in algebra, all operations are done more horizontally than vertically. But just to show you, I'll take this one for example, and I'll make a box out of it in case you did. So 10 goes here, this would be 2c plus 5, so this would be 20c plus 50. All right, so this is the end of video number 1, and then you can stay tuned for video number 2, which will do the rest of it.